Select the resulting tree from the following insertion and probability combinations and the following deletion with care as the type and int as the probability. So what we're going to do here is we're going to put in our insertions and deletions, and then we're going to work through the solution. So our first probability is D, 10. So that will definitely be at the root. And then we're going to have E, 47. So the way the tree works is we initially put this in, and we see that 47 is greater than 10. And then it's going to move up. So this will become E, 47, D, 10. The easier way to do this on exam would be to observe the first two, know that E47 should be higher than D10, and make D the left child of E like we have here. So this is where a good place to start would be. Next, you're going to have F and 18. So F18 actually comes here to the right, and 18 is less than 47, so it remains the same. A is going to become here initially, but we know this is going to switch up. So you could do this simply by saying, all right, I'm going to put A 37 here and D10 there. And then what we're going to see here is that 47 is greater than 37, so it remains in place. I'm sorry, D10 should be over here. So now what's going to happen is we are going to put in C92. So C should go here. And now what's going to happen is it's going to replace, C is going to become up here, D will become the right child of C. And then what's going to happen is C is going to replace it because 92 is greater than 37. So initially it'll be C92, A37, and D10. And then we have to consider what's going to happen with E. So C is going to move up, E is going to become the right child of C, and D will become the left child of E. So this would be C, and then this would be E47, D10, and F is going to still be F18, A37 will be over here. So now we need to insert B7. So B7 will just be over here, the right child of A. And then we're going to have G35. So G35 would initially be here. 35 is less than 47. So what we know we can do is we can move G here and make F the left child of G. So the problem asks for us to delete C97. So just like any normal binary tree, we take this largest element on the left and move it up. So this is going to move up here, and then we're going to have B7 up there. So the crucial part is we just keep moving this down until we account for everything. So what's going to happen is E is going to be larger than B. Now here's the crucial part. We still have to maintain the order. We can't just change these like we would do in a tree, in a heap, excuse me. So we would just rotate, and what's going to happen is E47 is going to become the new root, and then we would have B7 here, A37, and D10. All this is going to remain the same for the time being. What we have to figure out is which one's bigger here. So we have A37, D10. So A is going to come up, B is going to become the left child, and D is going to remain the right child. So then the final thing will be to account for these two. So B should become the left child of D. So it will look like this. It'll be A37, D10, B7, and then we would have E47 up here. Then we'd have G35 there, and then F18. And so this is going to be our final probabilistic tree. So let's take a look at what the solution should be. And we're going to see that A, this first choice, is the exact tree that we derived, so therefore A is the answer.